All right. So, final page out of our matrices bracket. All right, and this is partial fractions. This is a calculus skill that if you take calculus, and since this is called pre-cal, I just have to make the assumption that I am prepping all of you for a calculus class down the road. So this is a calculus skill. And like I said, typically when you learn how to do this, you learn how to do it using substitution, elimination, or either solving the system by doing matrices. But I'm going to show you a different method, which I personally think is a little bit easier. Does it take a little bit of time? Yes, but it's a little bit easier. Cannot hear you. Yell at me. I do not, because I just made enough for everybody to have a copy of itself. All right, so partial fractions. What we are used to doing is we are used to getting two fractions, the teacher asking you to add those together, and you come up with one answer. Partial fraction decomposition is the breaking down of that answer. I've told you before, the car cannot always go forward. Sometimes you have to put it in reverse and go backwards. So typically, on a good day, you are given this problem and you're asked to go that way. Well, I'm going to give you this and I'm going to ask you to break it up. And the individual fractions are called partial fractions. So when you work a fraction problem backwards and you are breaking it up, not functions, fractions. I said the right word and wrote the wrong one down. Okay. Now, we're going to take this particular example in the middle, 3x plus 2, x squared, or divided by x squared plus 6x plus 8, and we're going to actually do the first three steps. After that, we're not going to follow the rules on this page anymore. All right, so the first step says to take the denominator and factor it. So we're going to take x squared plus 6x plus 8, and we are going to factor it into x plus 2, x plus 4. Now, what comes next is we're going to write the given expression as the sum of two fractions, with a and b being the numerator and the factors of the denominator being the denominators. So we're going to take 3x over 2 divided by x squared plus 6x plus 8. And since we had two factors, two linear factors, I'm going to write a over x plus 2 plus b over x plus 4. All right, so that's how we start. Our goal is to figure out what a is so we can erase this a and put a number there, and figure out what b is so we can put a number there, and then we'll have our fraction broken down into the partial fractions. Okay, so the third step says to eliminate the denominators by multiplying by the LCD. So the LCD is always going to be the original denominator. Always. Okay, so I'm going to multiply everything in here by x squared plus 6x plus 8. Now, if you don't want to do it in that format, you can actually do it in factored form, x plus 2, x plus 4. Oops. I guess I am too close to the edge. Yep. So let me write that smaller, but I'm going to multiply all three of these fractions by x plus 2, x plus 4. Now, when I take all of this and multiply it here, it gets rid of the denominator. Those are the factors of the denominator. Okay? When I multiply it here, It gets rid of the x plus 2's, and that leaves me with a times x plus 4. And when I distribute it here, what does b end up being multiplied by? The x plus 2. Now, if you look at it, it almost looks like you are multiplying a in this denominator, b in this denominator. That's actually what's happening. But we have to do it by using the common denominator because you cannot cross multiply across addition. So in order to make it look that way, we have to multiply by the common denominator and get rid of the denominators, okay? So even though it kind of looks like that, you have to remember you cannot cross multiply across addition. Doesn't work that way. Now, these are the steps that we are not going to do. All right, so the next thing I want you to do is I want you to take each one of these denominators, each factor, and you're going to set each factor equal to 0. Now, these factors have to be linear. Linear means the biggest exponent is a 1. If this were x squared plus 3, what we're doing does not work, okay? Now, what I'm going to do is I'm going to take this first number, I'm going to plug it into the equation for every single x, and when I do that, it's going to eliminate something. Something's going to drop out. So I'm going to take 3 times negative 2 plus 2, set that equal to a times negative 2 plus 4 plus b times negative 2 plus 2. Now, negative 2 plus 2 is 0, correct? So b drops out. That's what I meant by something is going to drop out. The only variable I have left is a, and a just so happens to be the numerator of this fraction. So now all I have to do is clean this equation up now that b is gone, and I have my a value. So I get negative 6 plus 2, which is negative 4 on the left. I get a times 2, which is 2a on the right, and a ends up being negative 2. All right, so now what I can come up here and do is I can take a out of the picture and I can put negative 2 in its place. There you go. One numerator down, one to go. Do you know how I find the other one? I take this answer that I got from setting the factors equal to 0, and I'm going to plug it in. It's going to knock a out of the picture and leave me solving for b. So 3 times negative 4 plus 2 equals 2a times negative 4 plus 4, and negative 4 plus 4 is 0, so a is going to drop out, plus b times negative 4 plus 2. So on the left, we have negative 12 plus 2, which is negative 10. On the right, negative 4 plus 4 is 0, so the a drops out, and that gives me b times negative 2. So I end up with negative 10 equals negative 2b, and b ends up equaling to positive 5. So I come back up here, I erase the b, I put the 5. That is my answer. That is the partial fraction. We just put the car in reverse and backed up. Now, you could, the other option, I could put the 5 over x plus 4 first. And if you had written the factors as x plus 4, x plus 2, and you had that first, that's okay. You can write it as negative 2 over x plus 2, or You can grab that negative and pull it out in front and have it written as 5 over x plus 4 minus 2 over x plus 2. Do not double negative yourself. There's only one negative. A positive times a negative stays negative, so you can either leave it in the numerator or you can drop it to the front of the fraction. But don't do double negatives because that would become a positive, and that's not what our answer is. So there's 3 variations of how you can write the answer. But notice the 5 is over the x plus 4 in all 3 of them, and the negative 2 is attached to the x plus 2. That is important. It is not the same answer if you put the negative 2 here and the positive 5 here. Absolutely will not be the same answer. Everybody okay with that? No system, no matrices. All right. All right, we have 2 more examples. Actually, we have 3 examples, I believe. Is that how many y'all have left? Okay. So for the first one, you always factor the denominator, which is x minus 3, x plus 3. That's a difference of squares. I'm going to use the factors to set up my fractions. So I have a over x minus 3 and b over x plus 3. Now, if you had your x plus 3 first and your x minus 3 second, my a is going to be your b, and your a is going to be my b. Does that make sense? Your a and b. So if this were plus for you and minus here, our a's and b's are going to be the exact opposites of each other. You'll still get the same fractions, except you're just going to solve it in a different order. So if I take each denominator, set it equal to 0, each factor in that denominator, set it equal to 0, I have the values I'm going to plug in. But before I can do that, I need to multiply everything by x minus 3, x plus 3. Now, that is my least common denominator. The least common denominator will always be the original fraction's denominator. That's the easy part. So when you multiply here, you just get the 7x minus 15, because this would cancel with those factors. When you take that common denominator and multiply here, the x minus 3's cancel, and that leaves you with a times x plus 3. When you pull that common denominator all the way to the third part of this, that's going to give you plus b times x minus 3, because the plus 3's would cancel, and now we have no more denominator. So the first thing we're going to do is we're going to plug in 3 for x. That will make either the a or the b drop out, and we can solve for one of those variables. And then the second thing we'll do, or the thing after that, will be plugging in the negative 3. So 7 times 3 minus 15 gives me a times 3 plus 3 plus b times 3 minus 3. The b is going to drop out this time. Do y'all agree? All right. So that's 21 minus 15, which is 6, equals to 6a. 3 plus 3 is 6. And my a value is a 1. So I'm going to come over here. I'm going to take that a value out. I'm going to put a 1 in that numerator. And then I'm going to plug in negative 3 and figure out what my b value is. So 7 times negative 3 minus 15 equals to a times negative 3 plus 3 plus b times negative 3 minus 3. So this time the a value drops out because negative 3 plus 3 is 0. I end up with negative 21 minus 15 equals to b times negative 6. 21 minus 15 is negative 36 equals to negative 6b. So b is equal to 6. So I'm going to come up here. I'm going to take out my b, and I am going to put 6 right here. Everybody okay with that? Now, if you were to go backwards, if you were to find the common denominator, which means you have to change both numerator and denominator here and here, you would end up back at 7x minus 15 over x squared minus 9. Okay? Now, number 2 has a different type of linear equation or linear denominator because we have a 2 in front of it. The last one was a difference of squares. The first one had a 1 here. So we need to factor this. Does anybody remember how to factor when you have a 2 in front of that x squared? Okay. Oops, wait a second. My tablet decided it wanted to do something funky. So that's positive 6. What you going to do with that? You can rewrite it as x squared minus 7x plus 6. What are factors of 6 that add up to negative 7? Negative 6 and negative 1. The problem is x times x does not equal to 2x squared. Do y'all agree? So if you multiply the 2 in to get the 6, you have to divide the 2 right back out. 6 over 2 reduces flat out to 3. So one of my factors is x minus 3. 1 over 2 does not reduce or divide out evenly. So I'm going to take 2 and move it up here. My second factor would be 2x minus 1. Those are my factors. So when I set up my problem, negative 7x minus 9 over, and I'm going to go ahead and put the factors here. It doesn't matter if you use the 2x squared minus 7x plus 3 or the factored version of that. So a goes over the x minus 3. I just go in order with the way I write them down. If you want to put the 2x minus 1 in the first denominator and the x minus 3 in the second, that's fine. You can do that. Once you set up the problem, multiply everything by the least common denominator. What is the least common denominator? It will always be the factors of the original denominator. So we're going to multiply everything in that problem by the x minus 3, 2x minus 1. That's the original denominator. That's always your least common denominator when you do this. When I multiply here, it cancels everything, so I get negative 7x minus 9 equals, what will A end up being multiplied by? The 2x minus 1. And what does B end up being multiplied by? The x minus 3. So you can kind of see what's going on, how the pattern works, right? Now, x minus 3 equals 0. So the first number I'm going to plug in is 3, and it's going to give me either the A or the B. And then I'm going to take 2x minus 1 equals to 0. That gives me positive 1/2, and that will be the second number I plug in, and it will give me the remaining numerator. Okay, so negative 7 times 3 minus 9, that's negative 21 minus 9, which is negative 30. So the left side is done. The right side, A times 2 times 3 minus 1 plus B times 3 minus 3. So that knocks the b out because 3 minus 3 is 0. And this gives me a times 6 minus 1, which is 5a, and a is negative 6. So I'm going to come up here and I'm going to erase a, and I'm going to put negative 6 in its place. I'm going to take this equation and I'm going to plug in 1/2 next. So negative 7 times 1/2 minus 9 equals to a times 2 times 1/2 minus 1, or doesn't equal, that should be plus b times 1/2 minus 3. What drops out this time? The a value drops out. 2 times 1/2 is 1. 1 minus 1 is 0. So a drops out this time. So I get negative 7 over 2 minus 9. You will get negative 12.5. You get negative 25 over 2, which is negative 12.5. If you want to leave it as negative 25 over 2, that's fine. Equals to b times 2.5, negative 2.5, I apologize. One half minus 3 is the same as negative 2.5, or negative 2.5. Do y'all agree with that? All right. So what do you get when you divide both sides by negative 2.5? What is my b value? Positive 5. So I'm going to come up here. I'm going to erase that b value, and I'm going to put it 5 right there. Now, some of your homework questions simply want you to set up the scenario with a over something and b over something, and that's as far as they want you to go. And then other problems want the final answer. They want the partial fractions. So be careful when you do this homework assignment. Now, every denominator that we have dealt with has been linear, meaning the exponent is a 1. So in this bottom and third equation, I have a bigger denominator, but when I factor it, all the factors will still be linear. So the first thing I see is greatest common factor x has to come out because all three terms have an x. That leaves me the reduced quadratic of x squared minus 2x minus 3. And that quadratic can be broken down into linear factors. X minus 3 and x plus 1. Now, I don't have 2 factors this time. I have 3, and they're all linear. Exponent 1, exponent 1, exponent 1. So they are all linear. So I'm going to have 3 fractions this time. A over x plus b over x minus 3 plus c over x plus 1. As long as all your factors are linear, you can set your problem up this way. Everybody okay with that so far? All right, so now at this point, you can do one of 2 things. You can set each factor equal to 0 and figure out what you're plugging in, or you can multiply by the common denominator, which is always the original denominator. So when you take all of this and multiply here, you are left with just the numerator. When I take all of this and multiply it by the a over x, a stays, x cancels, and leaves me with x minus 3, x plus 1 that I have to multiply a by. When I drag that all the way to the b fraction, I'm going to have plus b times x plus 1, because the only thing that cancels is the x minus 3. It leaves me with the x and the x plus 1. All right. When I drag it all the way over to the c, what do you end up multiplying c by? X and x minus 3, because the x plus 1s would cancel, and that's all that's left is the c and the x minus 3. I like these because there is a method to the madness as far as the way you work it out. So once you get here, you need to know all three numbers. So I'll set x equal to 0 from my factors, x equals 0. From this factor, I get x equals to 3. And from this one, I get x equals to negative 1. Do you agree with those three numbers? So this time, I have to plug in three numbers because I have three numerators that I have to find. So we're going to plug in 0 first. And when you plug in 0, it actually knocks two of those key values out. It'll knock out A and B and leave C, or it might knock out A and C and leave B, or it might leave A and knock out B and C. But every time you plug in one of these numbers, two of these values will go away. Okay, so I'm going to plug 0 in first. So 0 squared plus 19 times 0 plus 12 gives me a grand total of 12 on the left-hand side. Now, on the right-hand side, 0 minus 3 and 0 plus 1. A is not going anywhere because that gives me A times negative 3 times positive 1, and that's not a 0. When I move over to the B fraction, B times 0 plus 1, B times 0 is 0, and 0 times anything, so the B drops out. When I do that to the C, I have the same exact scenario. C times 0 is 0, and 0 times anything will knock that out. So now I'm left with A equaling to negative 4. I have my first number. So I'm going to erase my A. Now, if you don't want to erase, you can just extend it over here and write it this way. If you want to leave your A, B, and C intact, you can always write three brand new fractions. It's totally up to you. All right, so we did that one. Now we'll take our 3. So that's negative 5 times 3 squared plus 19 times 3 plus 12. That's going to equal to A times 3 minus 3 and 3 plus 1. That drops out because 3 minus 3 is 0. Do y'all agree? Then I'm going to have B times 3 and 3 plus 1. That's not going to drop out because there's no 0 that ends up in there. Plus C times 3 minus 3, which drops out because this ends up being 0. So every time you do this, two of those things should drop out and leave you with just one. So grand total over here, what do you end up with when you plug in 3 for that left-hand side? You should end up with 24. This is 3 times 4. So all of this turns into 12B. So my B value is 2. All right. So I'm going to pause for just a minute, and I'm going to let you plug in negative 1 and get your C value out of it. You ready? What'd y'all get? -3 is correct. Okay. Now, this is nothing even remotely. The only thing that is remotely like what Math Excel will show you is when we get to this part right here. You factor the denominator, you set up your ABC fraction, whatever that is, and you create that equation. What Math Excel does after that, what the textbook normally does after that, is not what I just did here. Personally, to me, this is 10 times easier. Okay. Do y'all want to see what the other does? Somebody said sure, somebody's shaking their head. So I'm going to stop the video.